All right, picture this. You have exactly 20 minutes before the doors open for your physics mock exam. You're sitting outside the hall, frantically flipping through your flashcards, totally convinced that as long as you just get the math right, you'll effortlessly secure those top marks. Well, I'm here to shatter that myth right now. Listen, just getting the math right is absolutely not enough to survive the Cambridge IGCSE Physics 0625 paper. It's just not. So let's dive into what actually costs brilliant students their grade boundaries.
It is honestly terrifying how quickly you can lose marks if you aren't paying attention. First up, we have a painfully common, yet fundamentally flawed student answer. The student is trying to calculate an area, they multiply a length of 20 centimeters by a width of 10 millimeters, and they get an answer of 200. Now, sure, the pure math works out, 20 times 10 is 200, but the physics is completely broken. 200 what exactly? Now contrast that with the improved, top-band answer. This student spotted the trap. They took that 10 millimeters and converted it into 1 centimeter first. Then they calculated 20 centimeters times 1 centimeter, giving a final correct area of 20 square centimeters. That instant fix right there, that is exactly what secures the grade boundary.
So you're probably wondering, why do so many smart students make this exact mistake? Honestly, it's because ordinary revision completely ignores explicit examiner warnings. The Cambridge syllabus directly warns against using inconsistent units. The examiners aren't guessing. They know exactly where your blind spots are. They designed these papers specifically to test if you're actually paying attention to the physical reality of the problem, not just mindlessly punching numbers into a calculator.
Which means you need an unbreakable baseline before you even think about looking at an equation. Your very first quick win is locking down your basic SI units. The International SI system was agreed upon by scientists so we can all compare the sizes of variables and calculations easily, without any confusion. So, length or distance, that must be in meters, with the symbol m. Mass must be in kilograms, or kg, and time absolutely must be in seconds, or s. Memorizing these core units isn't just basic knowledge, it is step one of your exam survival strategy.
But here's where it gets tricky. Examiners take this baseline and use it to set deliberate traps. Sometimes they will give you different non-standard units for these exact same variables. An exam question might casually give you length in kilometers or millimeters and time in hours. If you take those alternative units and drop them straight into your equations without converting them back to your base SI units first, well, your final calculation will be entirely wrong and you will bleed marks.
The textbook actually shouts this warning at you. Take a look at this specific lookout box straight from the source material. It says, be careful with units when using equations. For example, when distance and time are measured in meters and seconds, the speed that you calculate will be a value in meters per second, not in kilometers per hour. I really want you to channel the examiner's mindset here. They are setting a trap. They are hoping you'll mislabel your final answer simply because you weren't watching your inputs closely enough.
When we combine these basic measurements, we create what's called a derived unit, basically a unit based on a calculation. Take meters per second for speed, for example. It's exactly what it sounds like, the number of meters traveled in each individual second. And that slash symbol you always see, it literally just means per and indicates division. But here is the crucial catch. Your derived units will always be completely wrong if your starting units aren't consistent from the very beginning.
Which brings us to a massive high-stakes question. How do you convert 50,000 cubic centimeters into cubic meters without losing a grade boundary? In a moment, I'll show you the exact examiner clue that catches out 80% of students and changes the answer completely. But first, you need the evaluation framework that makes that examiner trap completely obvious.
Okay, let's break down this master 4-step framework. This is exactly what you need to construct a top-band Cambridge physics answer. Step 1, identify the underlying concept. Step 2, extract the evidence and data directly from the question. Step 3, apply your scientific reasoning to figure out exactly how that data needs to change. And finally, step 4, use precise examiner wording to write out your final answer. Stick to this structure and you literally cannot be fooled.
Let's actually apply this framework right now using a classic example from the source text. The concept here is calculating area. The evidence provided to us is a rectangle with a length of 20 centimeters and a width of 10 millimeters. Now, our scientific reasoning dictates that these units are inconsistent, meaning that 10 millimeter width must become 1 centimeter before we calculate the area. And finally, the examiner wording requires us to explicitly show this mathematical step on the page to secure those full marks.
This brings us to a core rule. Choosing the correct unit is your very first fundamental math skill in physics. In any calculation, the units you use must match perfectly. They absolutely must be consistent with one another.
If your length is in centimeters, your width has to be in centimeters. No exceptions. This is an absolute, non-negotiable step. You need to check your units before your pencil even touches the paper to write out an equation.
Now let's escalate this to the harder examples where students really start to panic under exam conditions. Think about area conversions. To convert from square centimeters to square meters, you cannot just divide by 100. That's a huge mistake. Because you are dealing with an area, which is length times width, there are actually 10,000 square centimeters in 1 square meter. Think about it, that's 100 centimeters multiplied by 100 centimeters. Forgetting that extra dimension is a devastating mistake in an exam.
Let's raise the stakes even higher. What about volume? What happens when you need to convert cubic centimeters into cubic meters? Well, the conversion factor leaps to a massive 1 million. Why? Because volume is length times width times height. It's 100 by 100 by 100. If an exam question asks you for density in kilograms per cubic meter, but hands you a volume in cubic centimeters, you absolutely need this 1 million conversion factor to survive the question.
All of this builds into an ultimate conversion cheat sheet, straight from the source book. Let's break down the processes we're looking at here. Going from an original unit of centimeters to meters, simply divide by 100. Going from square centimeters to square meters, divide by 10,000. And from cubic centimeters to cubic meters, divide by 1,000,000. Take a mental snapshot of this right now. This is your absolute lifeline when you are under serious time pressure.
All right, now it's time for you to do the heavy lifting. This is a pause and predict challenge. I want you to pause this explainer right now and predict the conversions using the cheat sheet rules we just went over. Convert 500 centimeters, 5,000 square centimeters, and 50,000 cubic centimeters into their proper base SI units. Go on, really test yourself. I'll wait.
Okay, let's see how you did and apply some real examiner-style correction. Let's look at the common error first. A stressed student looks at 50,000 cubic centimeters and automatically just divides by 100, getting the whole question fatally wrong. But the top band method, that student recognizes that cubic centimeters is a measure of volume with 3 dimensions and correctly divides that 50,000 by 1 million.
Which neatly closes the loop we opened up earlier. When you take that 50,000 cubic centimeters and divide it by 1 million, you arrive at exactly 0.05 cubic meters. This right here, this is the exact, final, examiner-approved calculation that proves to the person marking your paper that you completely understand the physical dimensions of the problem. That is how you lock in your top band score. And keep in mind, this fundamental skill is absolutely required for the entire physics syllabus. Look at these advanced SI units. Force in newtons, energy in joules, power in watts, potential difference in volts. Every single one of these advanced derived units relies entirely on your base units being completely flawless. If you mess up a simple millimeter conversion early on, your final complex answer for joules or watts will be guaranteed incorrect.
But here's the massive unresolved problem you're now facing. Mastering these units, that is just step 1 of your exam strategy. Sure, fixing your units will save your calculations, but to properly evaluate practical investigations, spot anomalies, and absolutely guarantee your final grade, you must master the final week evaluation framework. Without it, you are still totally vulnerable. Your mock survival plan continues next with the last 7 days revision map. You simply cannot afford to walk into that exam hall without the full strategy in place. Will you fall for the unit trap, or will you secure your top band? Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Click the next explainer on your screen right now to master the final evaluation framework and complete your mock survival strategy. Don't leave your final grade up to chance.